Hi everyone, so looking at this next video, what we're going to talk about is Venn diagrams. We're going to talk about probability with Venn diagrams, okay? So we're going to go through the different types of notation, key things you need to be aware of, and some key points to revise. Worth making a flashcard on some of this to make sure you're happy with it. So let's start looking at, first of all, what we've got. This letter here, you'll see, basically just tells you that these are all the numbers that need to be included within the Venn diagram, okay? So everything in here has to go in here. That's basically what that's saying to you. It's telling you that the A circle, are all multiples of 3, and B has to be any even numbers. So the way that I would start this is, first of all, I'd go, right, what are all my multiples of 3? Well, 3, 6, 9, 12, 15, 18, and 21 would be my multiples of 3. This finishes at 20, so actually I don't need that last one there of 21. Let's think about all my even numbers. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, so by listing all the numbers, first of all, it means that you can make a really informed decision about what goes where. So the first thing I'm then going to look at is what shows up in both. Well, I can see straight away there's a 6 in both. If it is in both lists, it has to therefore go in the middle. What else is in both? I can see 12 is in both, so 12 has to go in the middle. And I can also see that 18 is in both as well, so 18 has to go in the middle. So in the middle of your Venn diagram, you should have 6, 12, and 18. There is nothing else that shows up in both lists. Therefore, for A, I can then write anything that's left over in A. So looking at that, I've got 3, a 9, and a 15. 3, 9, and 15. They are all my multiples of 3 that aren't even numbers. And then I can look at what's left here that doesn't go in that middle. So all of those values, 2, 4, 8, 10, 14, 16, and 20. So all those numbers have been dealt with. What I'm then going to do is I'm going to go to my list, my original list at the top here, and I'm going to cross off the values that I've already dealt with. So I've already dealt with 3, I've already dealt with 2, I've already dealt with 4, 5 I haven't put in anywhere, so I'm going to leave that there. I've dealt with 6, I haven't dealt with 7 yet, 8 is in there, 9 is in there, 10 is in there, 11's not, 12 is in there, 13's not, 14's in there, 15 is in there, 16 is in there, 17's not, 18's in there, 19's not, and 20's in there. So now I can see quite clearly the ones I haven't actually done anything with yet. So those ones there that I've circled have to go somewhere. Because they are not multiples of 3, and because they are not even numbers, it means they then have to go on the outside. So 1, 5, 7, 11, 13, 17, 19, all have to go on the outside. Now I know that there are 20 numbers there, so let's just double check I've actually got 20 numbers in my Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know every single number's been dealt with and that they're in the correct place. That would normally get you a couple of marks, possibly 3 in an exam. So I've done the Venn diagram. Right, this is what you now need to be aware of, what this notation means. So we've got probability A and B. We've got probability of A union B, and this A with a dash is something we need to talk about. So let's just quickly go down here and think about what these values actually mean. So A and B is basically the intersection, okay? So think about it a little bit like fish and chips, okay? You're having both things together. So therefore, if I think about what that would look like on a Venn diagram, if here is my Venn diagram, this value is A, this value is B. A and B means this middle section here. So it's the intersection, it is the middle part. That's worth writing down, put it on a flashcard, make a note of it, so you know that A and B, A intersection B, means the middle part. So let's look at this. This P means probability, okay? So we're talking about probability. So probability of A and B. Well, basically what we're saying is how many numbers are in this section here? Well, we know that there are 3 values in that. Okay, so we've got 3 values in that middle section, in that intersection, out of a total of 20 numbers altogether. So that would be your answer for the probability of A and B. You're not adding those values together. It's saying, what is the probability? If I had all these numbers in a bag, okay, what would be the probability I'd get one of those? Well, there are 3 of them out of 20 in total. Let's look at the next one. It says probability of A union B. So this means union, okay? And the way you can imagine this is thinking about it as the fact that that U in the middle is holding both the circles in your hand, and you are basically saying anything in there, anything in there, anything in there. So A union B means both circles, okay? Again, worth copying that Venn diagram there with the shaded bit. It's anything that shows up in both circles. So if we go back up here and look at this then, A union B, anything that is in this circle and in this circle, well, let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers in total. And this is out of a total of 20. Okay, so that would be 13 over 20. The final one that's quite common that comes up is this A with a dash. And this basically means not in A. The way I remember this is I think about it as that dash is telling you it cannot be. So imagine someone wagging their finger and saying to you, no, you can't do that. It's the same as thinking about that. You're saying, no, it can't be in A. So if I've got both my circles like this, and this one's A and this one's B, so if I'm saying not in A, it means it's got to be on the outside. It can be in B, so it can be in that circle there, but it can't be in that middle bit, because if I was to include this little bit here, that would also still be in A. So basically, it can't be in this A part. Okay, so let's go back up here and look at this. It says probability of not in A. Okay, well, that's in A, 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 and that's in A. So all of these can't be included in it. So what we're now looking at is all of these numbers here and these green ones. So we're looking at the purple and the green numbers. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would therefore be 14 out of 20. Okay, now you look at this last bit I've written here. I've also written this, which basically is exactly the same, and that would be not in B. So if it was that, for example, for this question, if the question said probability of B with a dash, that's so not in B, what we're therefore saying is it cannot be any of these green or red numbers. It would have to be the blue and the purple. So in that case, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'd be 10 out of 20, or you could say that becomes a half. If you wanted to simplify any of these fractions, you could. So this one over here would simplify to 7 over 10, but you don't have to with probability. Okay, so that's your key piece of information. What I've written here is worth writing down on a flashcard, so make sure you understand, and you could even use this as your example as well. So let's also look at a slightly different style with probability and Venn diagrams as well. So it might not always be just about numbers like this, where you're given a list of topics like this. It could also be where you were given some information about certain pupils and you need to fill in and find the overlap and fill in the Venn diagram. So let's have a little look at this one now and see what we would do. Okay, so key thing to think about here is we've got 80 pupils. So that's important. We're going to need to know that the total of this Venn diagram is going to be 80. So they're talking about which sport they prefer out of football or rugby. So football is this circle on the left and rugby is the circle on the right. Could be that they like both or they like neither. So the key to this is understanding, first of all, you've got this value of neither. So if these 20 pupils do not like rugby, they do not like football, therefore those 20 pupils are going to need to sit on the outside. So the first thing to think about is getting your outside value correct if there is an outside. Sometimes it might not be, but if there is one, get that in first of all. Now, it's also about understanding what this means. We've got 50 pupils that like football, which means 50 pupils need to be in the entirety of this circle. So it can be just in this part, but it can also be in this part as well. And we've got 25 pupils liked rugby, which means 25 pupils need to fit in this circle. So it could be in here, could also be in here. So when you're thinking about it, think about this wording very carefully. So if it said 50 pupils only liked football, then you could straight away put 50 here. But because it says liked football, it means they could either be in this bit or in the overlap. So we need to be careful with the wording. So let's look at the first process. We know that we have 80 pupils in total, and I've just put 20 in there. So straight away, I can take away those 20 pupils. So now I've got to put 60 pupils. So now I've got to put 60 pupils in this Venn diagram. if I look at the two values I've got here, I've got 50 pupils liking football and I've got 25 pupils liking rugby. Now, you'll probably straight away think to yourself, well, there's 50 that like football and then there's 25 that like rugby. So that altogether makes 75. But I need it to be 60. So this is the key to this question. The difference between these two numbers, so the difference here, is your overlap. So what I mean by that is the difference between 60 and 75. So you're doing the 75 minus the 60, which gives you 15. That means 15 sits in the middle of your Venn diagram. So let's just quickly recap what I've done. 80 pupils in total. You take away the 20 because we already know that 20 is definitely they don't like either. Therefore, there's 60 pupils left that I've got to deal with. There are 50 that liked football, so there's going to be 50 in this whole circle altogether, and there's going to be 25 in this whole circle altogether. Combining those together makes a total of 75. So in these two circles, I'm going to need to have a total of 75. And then the difference between the 75 and the 60 is 15. So 15 goes in the middle. Okay, now when we're looking at that, we can now start thinking about how this impacts this second part. Now I've just put 15 in the middle, and I know that in total 25 pupils liked rugby. Well, if 25 pupils like rugby and I've just dealt with 15, that means there are 10 left. So 10 are just rugby on their own, because now when I look at that, that whole circle adds up to 25. We need to then do the same for football. I know that in total 50 students said they like football. I've just accounted for 15. So you're doing 50 minus 15, which gives you 35. And so therefore that part makes 35. Double check yourself. 35 plus 15 gives you 50. So 50 pupils like football. 15 plus 10 is 25. 25 like rugby. 20 people said neither, so they sit on the outside. And now your final thing to do to double check that you are fully correct is add all that together. So 35 plus 15 plus 10 plus 20. And when you do that, it should end up giving you the total pupils. So that gives us 50, 60, 70, 80. So I know that that Venn diagram is correct because when I add it all up, I end up getting the total amount in the class survey. So that's how you do it when you've got an overlap involved. And then this last bit says find the probability of F and R. If you go back to this, thinking about what that means, so the F and R, this is your intersection. So therefore, you're just looking at that middle bit. How many pupils are in there? There are 15. So your answer here would be 15. And this time, you're out of a total of 80. Okay, so that's how you do that example when you've got a Venn diagram with a bit more of a worded kind of example as opposed to the previous one where it was all numbers. The last thing you need to be aware of is what it looks like if you end up having a three-way Venn diagram, which would only end up being on higher. So these two we've just done would be on foundation. The next one that we're going to go through would be just on higher. Okay, moving on then, let's have a little look at what this looks like with a three-way Venn diagram. So the reason we know it's a three-way Venn diagram is because actually in this sentence, so a group of 100 pupils are asked which flavour of Dorito crisp they prefer. So we've got cool original, tangy cheese, or chili heatwave. So they're your three different values. So in your Venn diagram, it's going to look like that. So that's your cool original, that's your tangy cheese, that's your chili heatwave. So a three-way Venn diagram has the three circles, and there's this middle section that is the overlap of all three. So it says 20 pupils didn't like any flavour. That's really easy to put in straight away. 20 goes on the outside. It says 12 liked all three equally. Well, that means that that middle section will be 12. Okay, so those two values are quite easy to put in. It now starts to get a bit tricky. You need to read between lines. You need to read stuff very carefully to understand exactly what it's saying to you. So it says here 46 pupils liked tangy cheese. Now what that means is that whole circle there has to make 46. Now, I've just dealt with 12, so technically I can take away the 12 straight away and know that 46 take away 12 gives me 34. So what that means is in this part here, and this part here has to add up to 34. That's if all three parts are indeed going to have something in them. So let's read what the rest of it says. It says 4 of these like tangy cheese and chili heatwave with no other flavour. So tangy cheese and chili heatwave, and they didn't like any other flavour, which means that that has to go in that section there. So that's your tangy cheese and chili heatwave overlap. It can't be in that one because that would also mean they like Cool Original as well, and it says they don't like any other flavour. So that means I'm going to take away that 4, and I've now got to fill in that, and that has to be 30. Well, let's see what it says. It says of the remaining pupils, they liked no other flavour. Right, so therefore that 30 has to go in that section there because none of the 30 can go in there because they didn't like any other flavour. So what I've done is I've filled in my tangy cheese section there. So let's rub all that working out now because we don't need that. I can tick that one, so I've dealt with that now. 18 pupils liked Cool Original only, which means that's my Cool Original. 18 only liked Cool Original, so they can't go in that section. They can't go in that section because they only like the Cool Original flavour. That's quite easy to fit in as well. And then it says 9 of the 32 pupils that liked chili heatwave. Okay, so 32 pupils liked chili heatwave, so that circle has to make 32. And it says 9 of them didn't like any other flavour. So that means that 9 has to go there. Now, I know that this circle has to add up to 32 because it's telling me 32 pupils like chili heatwave. I've got 12 from the middle section, so that therefore makes it 20. I've then got 4 from this section here, so I take away 4, which gives me 16. And then I've also got this 9 that I've dealt with here, so take away 9 means there's 7 pupils left. So 7 pupils have to fit in this circle, and because I've filled in all the parts already, 7 must fit in there. Okay, there is no other information that I'm going to look at, but what I'm now going to do is I'm going to double check that everything I've done works. So I'm going to add all these values together. 18 and 12 makes 30, plus 30 gives me 60, plus 4 gives me 64, plus 7 gives me 71, plus the 9 gives me 80, and then plus the 20 gives me 100. So I've now just double checked that that Venn diagram adds up to 100 because I know in the start of the question it said 100 pupils were asked which flavour of Dorito they liked, and my Venn diagram adds up to 100. If you add it all up and you've got a number that's greater than 100 or less than 100, it means you've made a mistake somewhere in your Venn diagram. Okay, so that's now what my Venn diagram would look like. Let's look at what the question says. It says find the probability I pick a person who likes Cool Original and chili heatwave and no other flavour. So that part there is really important. So Cool Original is this circle, chili heatwave, and no other flavour. So it can't be that section. Okay, it can't be that bit, it can't be that bit, it can't be that bit, it can't be that bit. So it's just that bit. So therefore it's 7 over 100. Okay, and it's out of 100 because we're talking about the whole group there. So that's your example of a three-way Venn diagram. It's very important that you read between the lines and you incorporate all the parts of the circle that you're looking at. Okay, so that's Venn diagrams. That's how we use it with probability. As I say, it's worth practicing a range of different probability questions to do with Venn diagrams so you can get your head around how they work. But all in all, it's just about taking your time over it, making sure you get the right pieces of information in the correct circles and work your way through it. Hope you found it useful. Hope it helped you, and I'll see you all in the next video.